This video is a continuation of video tutorials on civil engineering materials lab experiments. I am Usman Javed. I will be teaching you different lab experiments of civil engineering materials. In this video, we will discuss about the bulking of sand. How can we determine the bulking of sand? First, you must know the bulking. Bulking is basically a phenomena in which the sand particles move apart uh, due to the water layer which is surrounding the sand particles. The water layer makes the sand particles to move apart. So phenomena occurs when this phenomena occurs at a specified water content when the aggregates are exposed to. Here you can see that the sand grain particles. So these are being exposed to the water. The water has been encapsulated or form a layer around it. The interaction between the particles are removed, and the water layer moves apart. All these particles move apart so that they have a bulking, so they have a volume change. So the volume change within the sand particles, volume change of a sand particles is known as bulking. So how can we determine the bulking? There are two procedures. First one is basically uh, the sand is exposed to some specified moisture content. For example, you don't know about the water content or water absorption of a sand. For example, arbitrarily 5 to 6% water is added into the sand, overnight sand, and that sand um, is placed into the some cylindrical volume, like you can place it in cylinder and measure the total volume total volume of a sand. Then what you do is to fill the water up to the mark where the sand volume was observed. After a while, you will observe that the particles appears to move closer to each other and form a and settle at the bottom and form water layer above them, because the water has specific gravity of 1 and sand has a specific gravity around 2.5 and 6. So the water forms a layer above the sand. So in this way, the sand settles down. You must allow the sand to settle down for around 20 to 30 minutes so that it can settle down. Then you measure the drop in volume of a sand when the water is mixed. Let's say over here in this picture, you can see that a 20 centimeter is a sand column in some container, some cylinder, and after placing the water into the sand, and so that the level must be retained, the after the 25 to 30 minutes, you can observe that the sand column would be left as 16 centimeter. The decrease in the sand volume would be the bulking. If you check the percentage change in volume with respect to this one, with respect to its original, then it's a bulking. For example, you can calculate uh, by calculating like 20 minus 16 divided by 16. So we'll get the bulking. So over here's a 25% of a bulking of sand occurred. Secondly, there is other procedure that you can follow that you need, which is a little cumbersome. Uh, Additionally, after finding the bulking, you must have a value of a water content known. So you must take the sand sample and place it in oven for 24 hours at 110 degrees Celsius so that you can know the water content present in sand. So in this way, you can find the bulking as well as its moisture content or water content present in it. So the other procedure is basically, which is little. Uh, the other procedure is that you first oven dry the sand, and then add the different proportions of a water in it, of a known water in it, and record its volume. For example, you have a overnight sand in a water container, and then you add, let's say, 4 gram of 4% of a water in it, 4% by mass of a water in it, and then allow it for 30 minutes so that it can absorb the water. So after 30 minutes, you may record the volume of a sand. If the volume of sand is increased, then you record the percentage increase in volume of a sand. So by increasing the percentages with the incremental size of a 2% water content, you can record the corresponding bulking in it. So after recording the bulking, you can plot it like, on x-axis you have a percentage moisture, and on y-axis there is a bulking, percentage bulking. You will get to know the values of x and y-axis, that is moisture and percentage increase, and then plot it down. According to the literature, you can find that the finer sand experience the more bulking. On the other hand, the coarser sands experience the least. So the bulking exists. Bulking is significant between the 5 to 8% of moisture content. So uh, its implications are very deep. If you add the excess amount of water in concrete, and that water would be available to the sand, and if it's 5% or even 3 or 4% of a water within the concrete mix, then what will happen? The bulking will happen. It will increase the volume of a concrete for a time being, and after the hydration started, the water would be either evaporated, leached out of the concrete surface, or evaporated or absorbed by some hydration reaction. Then the water content would be reduced. Then the volume of a concrete would be changing. This change in volume would cause cracks. So the bulking causes the cracks within the concrete if it has a excess amount of water, if the water is not calculated based on their water absorption values. So bulking can cause the cracks in the concrete surfaces. These cracks can uh, cause the durability problems as the external agent penetrate into the concrete and cause a rusting in the steel, or some deterioration can cause to the concrete mix by leaching out the calcium hydroxide, some other minerals, so that your porosity of a concrete would increase and its longevity and serviceable life would be reduced. So in this way, you can understand the importance of a bulking in concrete. So, um, I hope you have understood the term bulking and its procedure. How can we find out the bulking of sand? In case of any questions, you can mention it in comment section. Hope you have enjoyed this video. Thank you for watching.